So here I am going to discuss the angle of deviation again. So let us write some notes here. Let us consider this is the interface or any mirror, a plane surface. This is the incident ring. And this one is the point of incidence. O is the point of incidence. Let us consider AO is the incident ring. Let us draw a normal at the point of incidence, normal to the surface, normal to the mirror. So this is the normal here. So if I is the angle of incidence, let us consider R is the angle of reflection, where OB is the reflected, right? And here angle made by the incident with the surface or reflected with the surface is known as the glancing angle. Already we have discussed about this. Now, now what is the angle of deviation? So here, in the absence of the mirror, the incident ray will travel in this direction. So what is this one? This is nothing but undeviated path of incident. Undeviated path of incident ray. Means in the absence of the mirror, the light ray will travel in this direction. Now what is the angle of deviation here? As the ray is traveling in this direction, in the absence of the mirror, the light should travel in this direction. Right? But due to the presence of the mirror, it has been deviated in this direction, along the OB direction here. So here, this is nothing but angle of deviation. So now the incident has to travel in this direction, but it has been deviated in this direction. So therefore, whatever we have calculated here, delta is equal to 180 minus 2i. This is the angle of deviation in anti-clockwise direction. So this is the formula for angle of deviation in anti-clockwise direction. Right. Now sometimes they may ask what is the angle of deviation in clockwise direction also. So angle of deviation in clockwise direction. So in clockwise direction means here remember, what is the definition for the angle of deviation? It is the angle between the incident ray direction and the reflected ray direction. Undeviated and deviated. So angle between the undeviated ray and the finally deviated ray, that is the angle of deviation. Now what is the angle of deviation in clockwise direction? This is the angle of deviation 180 minus 2i in anti-clockwise direction. Remember, this is nothing but anti-clockwise direction. Now, in clockwise direction, delta is equal to the total angle, it will be 360 degrees. So therefore 360 minus of, so 360 minus of 180 minus 2i. So this can be written as delta is equal to 360 minus 180 minus of minus plus 2i. So therefore delta is equal to 360 minus 180 is nothing but 180 plus 2i. So this is the angle of deviation in clockwise direction. Angle of deviation in clockwise direction. So you have to remember these formulas: angle of deviation in the anti-clockwise direction and angle of deviation in the clockwise direction. Right? The incident ray actually it is traveling in this direction, but due to the presence of the mirror, it has been deviated in this direction. So whatever we are taking the angle here, angle of deviation, it is in anti-clockwise direction. So what is the formula for the angle of deviation in anti-clockwise direction? 180 minus 2i, or else we can say here 180 minus 2r also. According to the laws of reflection, here angle of incidence it is equal to angle of reflection. So here we can write 180 minus 2i or else 180 minus 2r. Right. In clockwise direction it is 180 plus 2i or else 180 plus 2r also. Is that clear? Okay. Now, is that loss of reflection or valid for any surface? Means since here we are taking the plane surface, right? If we consider a curved surface, curved mirrors, is that loss of reflection or valid? Yes. Here, loss of reflection holds good for curved surfaces also. For curved surfaces or curved mirrors, right? For example, here, let us consider this is a concave mirror. So I am taking a here concave mirror. So in the next class, we will discuss about the different types of spherical mirrors here. So let us consider this is a concave mirror here. And this is the principal axis. A principal axis which is passing through the pole and the center of curvature of the concave mirror. Okay. So we are not discussing about the spherical mirrors here right now. We are discussing about the loss of reflection, whether it holds good or not. Right. Now let us consider here, this is the incident. So I am taking a parallaxial ray. Parallaxial ray means the ray which is close to the principal axis and parallel to the principal axis. So this is the incident ray here, and this point is the point of incidence. Let us consider O is the point of incidence. In the case of the spherical mirrors, the normal it is a line passing through the point of incidence and the center of curvature. So this is the normal in the case of the spherical mirrors. The line should pass us through the center of curvature and the point of incidence. Now what is the angle of incidence here? This is the incident ray. AO is the incident ray. So angle of incidence, angle made by the incident ray with the normal is known as the angle of incidence. Right. Now here, in between center of curvature and the pole of the spherical mirrors, there will be a principal focus, or else we can call it as the focal point also. Since the incident ray is parallel to the principal axis, after reflection, it will pass us through the principal focus. Whatever, it is the reflected ray here. So the angle made by the reflected ray with the normal is the angle of reflection. In this case also, suppose angle of incidence is equal to 30 degrees, then the angle of reflection it is equal to 30 degrees. Means loss of reflection holds good. Loss of reflection holds good in any type of surface. Right? This is the angle of deviation in terms of anti-clockwise direction. In clockwise direction 180 plus 2r. Right? And loss of reflection holds good for the curved surfaces, for the curved mirrors also. Here also angle of incidence it is equal to angle of reflection. So మీకు అర్థమైంది అనుకుంటున్నాను నేను. సింపుల్ కాన్సెప్ట్, ఈజీ కాన్సెప్ట్ నేను తీసుకున్నాను. నేను ఆల్రెడీ ప్రీవియస్గా ఏదైతే డిస్కస్ చేశానో అదే కాన్సెప్ట్ని ఇంకోసారి ఎక్స్ప్లెయిన్ చేశాను. కాకపోతే ఇది వచ్చేసి యాంటీ క్లాక్ వైజ్ డైరెక్షన్ 180 - 2y, ఇది వచ్చేసి క్లాక్ వైజ్ డైరెక్షన్. అండ్ లాస్ ఆఫ్ రిఫ్లెక్షన్ అనేది ఏ సర్ఫేస్ తీసుకున్నా సరే హోల్డ్స్ గుడ్. ఓకే, నా what about normal incidence? Normal incidence. What do you mean by normal incidence here? Suppose this is a plane mirror here. I am taking a plane mirror, right? Okay. Now suppose let us consider this is a point where I am taking the normal. This is the normal here. Now, if the incident ray, it is incident normally on the mirror, then it is called as the normal incidence. This is the normal incidence, right? Here I am taking this point as the incident ray, right? And O is the point of incidence. At the point of incidence I have drawn it normal, right? Okay. Now in this case, what is the angle of incidence? Now what is the definition for the angle of incidence? Angle made by the incident ray with the normal. But here incident ray is traveling along the normal itself. So what is the angle of incidence? Here the angle of incidence it is equal to 0. So angle of incidence it is equal to 0 means according to the laws of reflection, angle of incidence is equal to angle of reflection also. So therefore angle of reflection it is also 0. Means how the reflected ray will be, right? After reflection the reflected ray will retrace the same path. Then only the angle of reflection will be 0. Right. Here whatever I am drawing with the yellow color, this one indicates the reflected ray, and with orange color this is the incident. So what is the angle of incidence is equal to 0. This is known as the normal incidence. So as we know that according to the laws of reflection, angle of incidence is equal to angle of reflection. So therefore angle of reflection is equal to 0. So therefore angle of reflection is equal to 0. That is, it means that, remember this one, it means that reflected ray after reflection or incident ray after reflection or as reflected ray after reflection will retraces the same path in opposite direction. Retraces the same path in opposite direction. Okay, so if the angle of incidence is equal to 0, then the angle of reflection is equal to 0. Angle of reflection is equal to 0 means it means that after reflection the reflected ray will retraces the same path in opposite direction. Clear? Okay. Then what about the angle of deviation? So as we know that here angle of deviation formula it is equal to delta, it is equal to 180 minus 2i. I am taking it anti-clockwise direction only. Even though in the problems also if they did not mention about the direction, we have to consider the angles in anti-clockwise direction only. Right? Even in the problems if they did not mention about the angles direction, then consider angles are in anti-clockwise direction. Right? Okay. Now here, in this case here, what is the angle of deviation? So here, angle of deviation which is equal, I value it is equal to 0, or else if I write here minus 2i or 2, or also r value is equal to 0. So what is the deviation here? 180 degrees, or else we can write this one in as 2 pi radians also. And this is the maximum deviation. This is the maximum deviation. After one reflection on the plane surfaces, the maximum deviation suffered by the maximum deviation suffered by the incident ray is 180 degrees. This is equal to 180 degrees. Is that clear? Okay. దీంట్లో ఏమైనా డౌట్స్ ఉన్నాయా? నార్మల్ ఇన్సిడెన్స్ లో, సో నార్మల్ ఇన్సిడెన్స్ గుర్తుపెట్టుకోండి, యాంగిల్ ఆఫ్ ఇన్సిడెన్స్ 0 అయితే యాంగిల్ ఆఫ్ రిఫ్లెక్షన్ కూడా 0 అవుతుంది. మరి డీవియేషన్ ఏమవుతుందా? డీవియేషన్ బికమ్స్ మాక్సిమం. డీవియేషన్ వచ్చేసి మాక్సిమం అవుతుంది. క్లియర్? Okay. Now let us discuss about the regular reflections and irregular reflections. Irregular reflections, it is also called as the diffused reflections. Irregular reflections are also called as the diffused reflections here. So let us discuss about the regular and irregular reflections. It depends upon the surface on which the incident ray is going to incident. Suppose let us consider this is a smooth plane surface. This is the smooth surface, right? Now here I am taking a beam of parallel incident light. So what is this one? This one is the incident parallel beam. Since I am taking number of rays here, so that you have to call it as a beam. Now, at every point of incidence, angle of incidence is equal to angle of reflection. Means here whatever we are taking the angle of incidence, here also the same angle of incidence, here also the same angle of incidence. Now what about the reflected ray? If the angle of incidence is I, then loss of reflection holds good on any surface, therefore the angle of reflection will be IO. Means here, suppose this is the reflected ray. So whatever the angle of incidence, it is equal to the angle of reflection. This is the angle of reflection. Now, how the reflected rays look like? It is also a parallel beam. So, reflected parallel beam. Now, such a reflection, it is called as the regular reflection. This one, it is called as the regular reflection. Now, what are the important points in regular reflection? Here, suppose the incident parallel beam, it is having some energy of 100%. Of that 100%, this smooth surface will absorb some amount of energy. For example, let us consider 1 or 0.1%. The other remaining percent of energy will be traveled in a particular direction. Means that intensity will be maximum in some particular portion only. So for example, if I consider here, this is a portion where the intensity of light is max. So the here important point is that intensity of reflected light, intensity of reflected light will be maximum at some portion only, whereas the remaining portion intensity will decrease, right? Now suppose if I am taking the irregular surface here, let us consider this is the irregular surface. This is the irregular surface. Okay. Now let us consider the parallel incident beam. This is the parallel incident beam, right? A parallel incident beam. Now, at every point of incidence, we have to take a small portion. Let us consider a small area, small surface here. In this surface, we have to draw the norm. Here also, if we are taking this point, it is a small area. In this portion only, I am taking a normal here. Here also. Like this, we have to take a small portion at this point. Now, so at this surface, at this point, the surface will be lines. Means the normal we have to take here. So this is the normal at this point. Okay. What about the normal at this point here? This is the surface. So this is the normal at this point at A, point of incidence of the first ray. B, let us consider B is a point of incidence of the second ray. Now at this point here, this is the normal here. So let us consider C is a point of incidence of the third. Is that normals are the same here? Angle of incidence, if I consider here I is the angle of incidence, is that same I will be there here? No. Let us consider this is I1. So I1 is the angle of incidence at the point B. Let us consider I2 is the angle of incidence at the point of incidence C. Angle of incidence at C, I2, angle of incidence at B, I1, angle of incidence at point A is I. Whereas comparing here, at every point of incidence, at A point, at B point, at C point, the angle of incidence are same. So even though the surface is irregular, laws of reflection will hold good. Then after reflection, let us see how the reflected rays are. So this is the first reflected ray. This is the second reflected ray. And this one it is the third reflected ray. So whatever the angle of incidence here, angle of reflection will be the same. Angle of reflection will be the same. Here, the total intensity it is diffused. Whereas coming to the regular reflection, the total intensity it will be maximum at some portion only. But here, the light after reflection, incident light after reflection on the irregular surface, it has been diffused. Diverges. The reflected ray diverges. So therefore, such a reflection it is called as the irregular reflection. Irregular reflection. Now what about the important point? what is the intensity here. In this case, intensity of reflected ray, intensity of reflected ray will be diffused in all directions. Will be diffused in all directions. Right. Oh. Whereas coming to the regular reflection, intensity will be maximum at some portion. Now, due to the regular reflection, we cannot see the object directly. Means suppose here, if you are placing your eye position and you are seeing here, you cannot see the portion of the mirror. Suppose my eye position ikkada undanukunnam. మీ ఐ పొజిషన్ ఇక్కడ ఉంది, మీరు రిఫ్లెక్టెడ్ రేస్ ని రిసీవ్ చేసుకుంటా ఉన్నారు. రైట్, ఇది అర్థం అనుకుందాం. ఇది అర్థమైతే మీరు ఎప్పుడైతే రిఫ్లెక్టెడ్ రేస్ ని రిసీవ్ చేసుకుంటా ఉంటారో, ఇక్కడ సపోజ్ మీ ఐ పొజిషన్ ఇలా ఉందనుకోండి. దిస్ ఇస్ ద ఐ పొజిషన్ హియర్. రైట్, మీరు యూ కెన్ నాట్ సీ. ఇక్కడ వచ్చేసి ఈ సర్ఫేస్ ఏదైతే మిర్రర్ అంటున్నామో, ఫర్ ఎగ్జాంపుల్ స్మూత్ సర్ఫేస్ మిర్రర్ గా కన్సిడర్ చేసుకున్నాను అనుకోండి, దెన్ యూ కెన్ నాట్ సీ ద మిర్రర్ ఇన్ దిస్ పోర్షన్. డైరెక్ట్ గా ఎవరైనా అద్దం తీసుకొని మీ పైన షైన్ చేస్తూ ఉన్నాడు అనుకుందాం. అద్దం తీసుకోండి, ఇన్సిడెంట్ రేస్ అద్దం మీద పడుతున్నాయి. ఆఫ్టర్ రిఫ్లెక్షన్ ఏవైతే రేస్ పడుతున్నాయో ఆ రిఫ్లెక్టెడ్ రేస్ అంతా కూడా మీ ఫేస్ మీద వేస్తున్నాడు అనుకుందాం. అప్పుడు ఎలా అనిపిస్తుంది? ఒక గోడ పైన వేసాడు అనుకోండి, ఫర్ ఎగ్జాంపుల్ ఆ రిఫ్లెక్టెడ్ రేస్ ఒక గోడ పైన వేసినప్పుడు మనకు స్పాట్ లాగా అనిపిస్తుంది, ఒక బ్రైట్ స్పాట్ లాగా అనిపిస్తుంది. అంటే ఆ బ్రైట్ స్పాట్ అంటే ఏంటి? అక్కడ ఇంటెన్సిటీ అనేది ఎక్కువగా ఉంది. క్లియర్? ఇప్పుడు ఆ స్పాట్ తీసుకెళ్లి మీ ముఖం మీద వేసాడు అనుకున్నాం, మీ కళ్ళ పైన వేసాడు అనుకున్నాం అనుకోండి, కెన్ యూ సీ ద మిర్రర్? నో, మీరు ఆబ్జెక్ట్ ని చూడలేదు. కానీ ఇదే ఇక్కడ ఈ పొజిషన్ లో తీసుకున్నారనుకోండి, and your eye position ikkada unna, this is your eye position here, idi me eye position antunna. So regular reflection lo entite intensity pass avutundo me eye lo, so that we cannot see that object. Kani ikkada intensity taggipotundi kada, you can see the object clearly. ఇప్పుడు దీనిపైన ఏదైతే లైట్ ఇన్సిడెంట్ అవుతుందో, ఇన్సిడెంట్ అయిన తర్వాత నేను రిఫ్లెక్షన్ ఆ రిఫ్లెక్టెడ్ రేస్ ని రిసీవ్ చేసుకుంటా ఉన్నాను. నా ఈ బోర్డ్ ని నేను చూడగలుగుతున్నాను, ఈ ఆబ్జెక్ట్ ని నేను చూడగలుగుతున్నాను. ఇట్ మీన్స్ దట్ ఇట్ ఈస్ ఎ ఇర్రెగ్యులర్ రిఫ్లెక్షన్. మీకు చూడడానికి స్మూత్ గా అనిపిస్తుంది కానీ, బట్ ఆఫ్టర్ రిఫ్లెక్షన్ ఏదైతే ఇన్సిడెంట్ అయిన తర్వాత రిఫ్లెక్షన్ జరుగుతుందో, ఆ రిఫ్లెక్టెడ్ రే అంతా కూడా డిఫ్యూషన్ జరుగుతుంది. అంటే ఇంటెన్సిటీ అనేది స్ప్రెడ్ అయింది. క్లియర్? ఫర్ ఎగ్జాంపుల్ ఇప్పుడు ఒక మిర్రర్ తీసుకుందాం. మిర్రర్ లో we can see our image, రైట్? మిర్రర్ లో వచ్చేసి మన ఇమేజ్ మనకు కనిపిస్తూ ఉంటుంది. సరే, ఇప్పుడు న్యూస్ పేపర్ తీసుకుందాం. మరి న్యూస్ పేపర్ లో మీ ఇమేజ్ ఎందుకు కనిపించట్లేదు? ఇప్పుడు న్యూస్ పేపర్ చూడడానికి బాగా స్మూత్ గా ఉంటుంది. క్లియర్? న్యూస్ పేపర్ ఇట్ ఈస్ వెరీ స్మూత్ గా ఉంటుంది. Can you see your image in the newspaper? No. Why? Irregular reflections. అంటే మీ దగ్గర నుంచి వచ్చిన ఇన్సిడెంట్ రేస్ అన్ని కూడా ఆ న్యూస్ పేపర్ మీద పడిన తర్వాత అది ఏమవుతుంది? మొత్తం డిఫ్యూజన్ జరుగుతుంది. సో ఆ డిఫ్యూజన్ జరగడం వల్ల ఏమవుతుందంటే మీ ఇమేజ్ అనేది మీకు కనిపించడం లేదు. న్యూస్ పేపర్లో ఒకసారి ఈ క్వశ్చన్ అడిగి ఉన్నాను నాన్న, ఎంసెట్ లో అడిగి ఉన్నాడు. న్యూస్ పేపర్లో why you cannot see your image in the newspaper? Any question here? What is the reason here? Due to the irregular reflections, the image is not formed in the newspaper. Is that clear? అర్థమవుతుందా? మనం ఏదైనా ఆబ్జెక్ట్ చూడాలంటే మనం ఏదైతే రిసీవ్ చేసుకుంటున్నామో రిఫ్లెక్టెడ్ రేస్, ఆ రిఫ్లెక్టెడ్ రేస్ ఎలా ఉండాలన్నా రెగ్యులర్ గా ఉండాలా లేదా ఇర్రెగ్యులర్ గా ఉండాలా? ఇర్రెగ్యులర్ గానే ఉండాలి. ఎందుకంటే ఇంటెన్సిటీ మనం ఏదైతే ఎనర్జీని రిసీవ్ చేసుకుంటున్నామో అది తగ్గిపోతుంది. సో దట్ వి కెన్ సీ ద ఆబ్జెక్ట్స్. ఇప్పుడు ఇవన్నీ కూడా ఇక్కడ మన ఆబ్జెక్ట్స్ అన్ని కూడా గోడ చూస్తున్నాను, ఏదేది రాస్తున్నాను, ఇదంతా ఈ గోడ చూస్తున్నాను, టేబుల్ చూస్తున్నాను, ఎవ్రీథింగ్ నేను ఇక్కడ ఉన్న వస్తువులన్నీ కూడా నేను చూస్తున్నానంటే బికాస్ ఆఫ్ irregular reflections only. Is that clear? This one it is also called as the diffused reflection kuda. Okay. Now